In our previous session together, we learned that a squared is actually equal to a multiplied by a. However, we can also think about a squared in terms of area. For example, in this perfect square, where the length of one side is a, we can describe the area of that square as a times a, or a squared. Thinking about squared numbers in terms of area is actually really important when it comes to learning about Pythagoras' theorem. Pythagoras' theorem, or his big idea, was that a squared plus b squared would equal c squared. But what is a squared, b squared, and c squared, you might ask? Pythagoras decided that the longest side of the right-angled triangle should be always called c. But he also created a fancier name for the longest side of the triangle, which you might have already heard of. It's called the hypotenuse. The other two sides, A and B, are simply the remaining shorter sides of the right-angled triangle. One other fancy little trick to always make sure that you label the hypotenuse correctly is that the longest side, or the hypotenuse, better known as C, is always directly opposite the right angle. So if you find the right angle in your right angle triangle, straight across to the other side, you will always find letter C. But let's get back to the formula. So Pythagoras decided that a squared plus b squared would equal c squared. But what does this mean? Well, going over across to our little triangle, the length of A being the length of this side of the triangle, squared, because it's squared, plus the length of B being this side of the triangle, again, squared, because it's squared, should always equal the length of this side of the triangle, which is C, again, squared, because that's in our formula. So let's see if this works with our right-angled triangle. The length of A squared gives me an area, which is A multiplied by A. The B side of the triangle, if I am to square this length, that will give me an area of B times B. And finally, if I'm to take my hypotenuse over here and square this length, that will give me an area which is C times C. So, looking at my very fancy drawing there, if Pythagoras is right, the area of A times A plus the area of B times B should equal the same amount of area as C times C. Let's test it out. So, using this one I've prepared a little bit earlier, I'm going to take the area of A squared over there, the area of B squared down here, and see if it's going to fit or be equal to the area of C squared up there. So, here we go. I'm going to take the A, I'm going to put him about the middle there, and I'm going to take a little B squared, a bit more of my B squared, B squared, and with a little bit of adjusting, ta-da! The area of A squared plus the B squared that I may have chopped up completely covers and is equal to the area of C squared. So it turns out that good old Pythagoras, his theory was correct. So what do you need to know by the end of today's session? Well, you should be able to remember wonderfully well now Pythagoras' theorem, which is a squared plus b squared equals c squared. You should also be able to show me what a right-angled triangle looks like, just like the one I prepared earlier. A right-angled triangle has, shock, a right angle in it. And a right angle is simply another way of saying 90 degrees. you should also be able to label our right-angled triangle using A, B and C. So let's do that together now. C is the length that we label first, and C is the longest side. This one here. It's also, remember, directly opposite our right angle, and we can call it the hypotenuse as well. Once you've labelled C, the other two are easy. A and B are our shorter sides, and it doesn't actually matter whether you call this one A or this one A, as long as you've got C in the right place. So A and B are our leftovers. Look at that, a perfectly labelled right-angled triangle.